This is a level 2 maths presentation on areas and perimeters. And the aim of the session, we're going to show you how to calculate perimeters and areas, and also how you can use formulas to work out the areas of triangles and circles. You'll need something to write with, and you can also use a calculator. To calculate the perimeter, the length around the outside of a shape is called the perimeter. A perimeter is calculated by adding together all the lengths of the sides of the shape. In terms of the shapes that you may be asked to work perimeters out for, you might be working with might be trying to work out the perimeter of a regular shape, which has sides with equal or opposite lengths, as demonstrated here on the left-hand side of the screen. This may cover problems like working out the perimeter of a swimming pool or a tennis court. But at level 2, you may be asked to work out perimeters for irregular shapes, as shown here on the right-hand side of the screen. They may be plans for a patio or a farm pen. Quite often with perimeter problems, you will be given sides, or you'll be given shapes in which you have no measurement showing on one side. If we have a look at this shape here on the left-hand side, we can see we have a series of measurements showing us the lengths of certain sides of the shape. But we have a missing measurement here on one of the horizontal sides, which runs from left to right, and a missing measurement here for one of the vertical sides, which runs from top to bottom. Now, because there are partial lengths on the other sides of the shape, we have two vertical lengths on this side of the shape, one of 4 centimeters and one of 3 centimeters. And we have one partial horizontal length here running from left to right, which is 2 centimeters. In order to find our missing lengths, all we do is, in the case of wanting to find the missing vertical length, we can add together the two vertical lengths that we have here on the right-hand side of the shape, which should be 4 centimeters plus 3 centimeters. And that would tell us then that the length of the vertical shape, the vertical side, is 7 centimeters. For the missing horizontal length here, we have a complete horizontal length of 6 centimeters. We have a horizontal length here which has been cut in at 2 centimeters. So in order to find out the missing horizontal length for this side here, which is not complete, all we do is we take the complete horizontal length of 6 centimeters, take away the 2 centimeter length that's been cut into the shape, and that tells us that the missing horizontal length would be 4 centimeters. So we're going to get you to do a perimeter quiz in which we want you to find the length of the missing sides and then work out the complete perimeter of each shape. So find out the missing lengths in each shape, and then when you found those missing lengths, add them together with the lengths that you have in order to work out the complete perimeter of the shape. If you're trying to work out how many lengths you will need in order to add them all together to get the complete perimeter, look how many sides that you have, and that will tell you how many measurements you're going to need to work out altogether. So for shape 1, we can see we've been given 4 measurements, 1, 2, 3, 4, but we have 2 sides here, one horizontal one running on the top, and one very small vertical one, which doesn't have a measurement attached to it. So we need to find the missing lengths for 2 sides. So in all, we're going to add together 6 measurements in order to get the complete perimeter. There will now be a 10-second gap before I go on to the next slide. So you may like to put the video on pause while you work out the missing lengths and the complete perimeters for each of those shapes. So the answers to those complete perimeters. The perimeters of the shapes were 52 centimeters, 94 millimeters, 9 meters, and 17 centimeters. Areas. The area of a shape covers the surface area of the shape and how much space that covers. An area is calculated by multiplying the length of one side of the shape by the width of one side of the shape. So for example, what is the area of a shape measuring 11.8 centimeters by 6.5 centimeters? So we just do 11.8 times 6.5, and that would give us an answer of 76 centimeters squared. All areas are presented in square measurements. So whether it's centimeters squared, meters squared, millimeters squared, depending on which unit of measurement you're using, you just do the multiplication. The length of one side by the width of the other. And it's the process to follow if you're working out the area of a regular shape like a square or a rectangle. However, you may be asked to work out the area of an irregular shape, and if that's the case, you're going to have to split that shape into two or more regular shapes. What you would then do is you would split those areas into, you would split those shapes, you'd multiply the length and width of those regular shapes to calculate the area of those shapes, and then add the areas together in order to calculate the total area of the shape. And the reason why that's needed is because if we look at this shape here, we have one length which is 6 centimeters and one length which is 9 centimeters, but they're not equal lengths all the way around. The length of this shape, the width of this shape on this side is not the same sized width on this side. So that's why the shapes have to be split up into regular shapes. Use multiplication to calculate the area of those shapes, and then add them together to get a total area for the whole of the shape. So we're just going to show that in context here. We have a shape here in which we have a length of a length of 15 centimeters, a width of 9 centimeters, another length of 9 centimeters here. We have a width of 11 centimeters. It is an irregular shape. So what I've had to do is to break the shape up into two separate shapes. And I do that by just drawing a line from one part of the shape down so that I can split it into two regular shapes. I have here effectively a square and a rectangle. Shape 1 here, based on the measurements we've been given, measures 9 centimeters by 9 centimeters. So the area of shape 1 would be 81 centimeters. Shape 2 measures 11 centimeters by 6 centimeters. And how I've worked that out is because the horizontal length at the bottom here is 15 centimeters. Its opposite length is 9 centimeters before it cuts off. So what I've done is I've just done 15 take away 9, and that's shown me that the horizontal lengths on shape 2 are worth 6 centimeters. So I do 11 centimeters times 6 centimeters. That means the area of shape 2 is going to be 66 centimeters. So what I now do is add the area of the two shapes together. So the area of shape 1, which was 9 times 9 to equal 81 centimeters, plus the area of shape 2, which was 11 times 6, which gave an answer of 66 centimeters. 81 plus 66 gives a complete area for this shape of 147 centimeters squared. So we're going to ask you to have a look at a couple of regular shapes. You will need to make those into regular shapes, calculate the areas for those regular shapes by multiplying the length by the width, and then add the two areas, or two or more areas if you get them, together to give you the total area for those shapes. There are 4 shapes in total. So you might like to put this one on pause while you move on to, while you work out the areas for these shapes. When I finish speaking, there will be a 10-second lag before I bring up the next set of shapes for you to calculate areas for. And here are the second set of shapes for you to calculate the areas for these irregular shapes. Okay, here are the answers that we got. For the first shape, the total area for the shape, for shape number 1, was 66 centimeters squared. That was done by breaking the shape into two regular shapes. We had one part which was 9 centimeters by 5 centimeters, so that gave an area of 45 centimeters squared. The second shape gave us an area of 7 centimeters by 3 centimeters because we had a horizontal line of 12 centimeters. We took 5 centimeters away from that, so that gave us a horizontal length on the second shape of 7 centimeters by 3 centimeters. So that came to an area of 21 centimeters. Add the two areas together, 45 plus 21 equals 66. For shape number 2, the complete area was 174 millimeters squared. So this was broken up. We made this shape into two regular shapes. So we had a shape at the top here, which was 6 meters multiplied by 9 meters, 9 by 6, which gave an area of 54 millimeters. And then the second shape here, we had to work out the length of the horizontal on the second regular shape. Well, we had a 14 millimeter length up to this point and a 6 millimeter horizontal length running along the very top of the shape. So add those together, that gave a length of 20 millimeters, a horizontal length of 20 millimeters for the shape, multiplied by a 6 millimeter width, which was calculated because we had a 15 millimeter vertical length running all the way down that side. But we took 9 millimeters away from that length on our first shape. So that meant 15 take away 9. That gave a length of 6 millimeters at the bottom. So 20 millimeters times 6 millimeters equals 120 millimeters. Add those two areas together, 120 plus 54 gives a grand area of 174 millimeters. For the second two shapes, the total area for shape number 3 was 288 centimeters squared. So in the first instance, that was done by breaking the irregular shape into two regular shapes. So we had one shape here, which was 16 centimeters by 12 centimeters. That came to 192 centimeters. We then had to work out lengths for this second shape. And what we came up with was 12 centimeters by 8 centimeters. The reason for that is that the horizontal length on the second shape was opposite a 16 centimeter length, but 4 centimeters of that length were taken out. So that meant that we had a horizontal length on the second shape of 12 centimeters and a vertical length on that shape of 12 centimeters, while the horizontal length, the total horizontal length was 20 centimeters, but 12 centimeters of that length was taken out at the top of that shape. So that meant that we had 8 centimeters left. So we did 12 times 8, that came to 96 centimeters. Add the two areas together, 192 plus 96 equals 288. And the final shape that we came to, that came to a grand area of 24.6 meters squared. That was done. Again, we split the shape into two regular shapes. We did 5 times 1.5 for the first one, which gave us an area of 7.5 meters squared. Then we had a 4.5 meter length on the second shape, and multiplied that by that was a 4.5 meter horizontal length, and multiplied it by a 3.8 meter vertical length, which we got because that was opposite a 5 meter length, but we took away the 1.2 meter length at the top of the shape. So 5 take away 1.2 equals 3.8. 4.5 times 3.8, it comes to an area of 17.1 centimeters. 7.5 plus 17.1 gives a grand area of 24.6. We're now going to look at area formulas in a triangle. So when working out the area of certain shapes, you'll need to use a formula. The area of a triangle can be found by using the formula base times height divided by 2. It can also be done if you halve the base before you start and then multiply your answer by the height. So if we have a triangle with a base of 10 meters and a height of 2.5 meters, we'll get the same answer regardless of which formula we use. So in the case of the first one here, where I'm doing base times height divided by 2, 10 times 2.5 equals 25. 25 divided by 2 gives us an area of 12.5 meters squared. If though I was to start by just halving the base before I start, half of 10 equals 5. And then I multiply that 5 by 2.5, that gives me 12.5. So use whichever method you feel most comfortable with. I tend to do base times height divided by 2, but the choice is yours. So we'd like you to work out the areas for the following triangles. There are 3 of them altogether, one with a base of 6 meters and a height of 4 meters, one with a base of 40 centimeters and a height of 80 centimeters, and the third with a base of 3.6 meters and a height of 2.5 meters. There'll be a 10-second gap before we go on to the answer slide. So you may like to put the video on pause. So the answers to these area of triangles, the first one has an area of 12 meters squared. 6 times 4 equals 24. Divide by 2, that gives us an answer of 12. The second triangle had an area of 1600 centimeters. 40 times 80 equals 3200. Divide by 2 to equal 1600. And the third triangle had an area of 4.5 meters squared. 3.6 times 2.5 equals 9. Divide that by 2 to get 4.5. You may also be asked to work out the area of a circle, and the formula that you use to do this is pi times the radius squared. That symbol is pi, and in number terms that is worth 3.14 times the radius squared. The radius is half the width or diameter of the circle. Once you've worked out what the radius is, in order to square it, you multiply it by itself and then multiply that answer by 3.14. That will give you the area of the circle. Let's have a look at a few examples. In this circle, the radius has been given as 5 centimeters. So we would need to square that radius by multiplying it by itself. So 5 centimeters squared equals 25 centimeters, because we do 5 times 5 in order to square that number. We then multiply that 25 by 3.14, which is pi. 25 times 3.14 gives us a final area on that circle of 78.5 centimeters. Sometimes you may be asked to work out an area in which you're given the diameter of the circle. So you'll need to halve that diameter in order to get the radius, and then to be able to start calculating the area of the circle. So in this circle here, where the diameter is 16, we do 16 divided by 2. That gives us 8. So the radius is 8. We now square that radius by multiplying it by itself. So 8 squared, 8 times 8 equals 64. And we now take that figure 64 and multiply it by pi, 3.14, and that gives us a final area of 200.96 centimeters squared. So using that formula, pi times radius squared, we'd like you to work out the area of circles which have a radius of 9 centimeters, a diameter of 24 meters, a radius of 6.7 meters, and a diameter of 1.8 meters. And remember to please give your answers to 2 decimal places. There'll be a 10-second lag before I go on to the next slide. And here are the answers for those areas. The first one would give you an area of 254.34 centimeters squared. We had the radius, which was 9 centimeters, so 9 squared equals 81. 81 times 3.14 equals 254.34. The second circle had an area of 452.16 meters squared. We were given the diameter first, which was 24 meters. 24 divided by 2 equals 12. So the radius was 12 meters. 12 squared, 12 times 12 equals 144. Times that by pi, 3.14, and that gives you the final answer of 452.16. The third circle gave you an area of 140.95 meters squared. We had a radius of 6.7 meters, which when we squared it, 6.7 times 6.7 came to 44.89. We then did 44.89 times 3.14, and that gave us the answer of 140.95. And then finally, the fourth circle gave us an area of 2.54 meters squared. We were given the diameter, which was 1.8 meters. Divide that by 2, so that gave us a radius of 0.9. We then squared 0.9 by multiplying it by itself, so 0.9 times 0.9 equals 0.81, and then 0.81 times pi, 3.14, gave us a final area of 2.54. So in summary, regular shapes, squares and rectangles, will have their area calculated by multiplying the length by the width. Irregular shapes need to be split into 2 or more regular shapes. The areas of these can then be calculated and added together to show the shape of the irregular shape. Areas of triangles can be worked out by doing base times height and then dividing the answer by 2, or halve the base figure and then multiply it by the height. And the area of a circle is found by using the formula 3.14 times the radius squared. And just add it in there at the bottom, add up all the lengths of a shape to calculate its perimeter. If you wish further work on this, go into your BKSB account, go to Maths Reforms, into Measure, Shape and Space, and in the Measure section, you'll be able to work through the perimeter, area and volume section.